Good day, province of Davao de Oro, and hello, Z Radio listeners. Basta Z Radio, siguradong lingaw, siguradong kuyaw. Welcome to Grade 9 Science. Here, we do not only bring you the facts, but we also bring you the fun. I am Teacher Parts of Lorenzo S. Sarmiento Senior National High School. With me is Ma'am Sheila from Attorney Orlando S. Rimando Senior National High School. Today's topic will focus on Grade 9 Science, specifically on Quarter 2, Module 2, which entitled The Formation of an Ionic and Covalent Bond. Are you now ready? Great! But first, I want you to bring out your module and we will answer questions 1 to 5 in your pre-test. Let's begin!
Let us now begin with our pre-test. Here's the instruction. Choose the letter that corresponds to the correct answer. Write the letter of your answer on a separate sheet of paper. Question number 1. Ionic bonds are formed between A. Two metals, B. Two nonmetals, C. Two non-reactive elements, D. Metals and nonmetals. Again, ionic bonds are formed between A. Two metals, B. Two nonmetals, C. Two non-reactive elements, D. Metals and nonmetals. Question number 2. In forming ionic bonds, A. Electrons are shared by two metals, B. Electrons are transferred from nonmetals to metals, C. Electrons are accepted by metals from nonmetals, D. Electrons are released by metals and accepted by nonmetals. Again, in forming ionic bonds, A. Electrons are shared by two metals, B. Electrons are transferred from nonmetals to metals, C. Electrons are accepted by metals from nonmetals, D. Electrons are released by metals and accepted by nonmetals. Question number 3. Reactive metals are mostly found at the A. The right part of the periodic table, B. Left part of the periodic table, C. Middle part of the periodic table, D. Lower part of the periodic table. Again, reactive metals are mostly found at the A. The right part of the periodic table, B. Left part of the periodic table, C. Middle part of the periodic table, D. Lower part of the periodic table. Question number 4. Reactive nonmetals are mostly found at the A. The right part of the periodic table, B. The left side of the periodic table, C. Middle part of the periodic table, D. Lower part of the periodic table. Again, reactive nonmetals are mostly found at the A. The right part of the periodic table, B. The left side of the periodic table, C. Middle part of the periodic table, D. Lower part of the periodic table. Number 5. In order to have a complete transfer of electron or electrons, the electronegativity difference of the two combining elements must be A. Less than 1.9, B. Greater than 1.9, C. Equal to 4, D. Equal to 0. Again, in order to have a complete transfer of electron or electrons, the electronegativity difference of the two combining elements must be A. Less than 1.9, B. Greater than 1.9, C. Equal to 4, D. Equal to 0.
Students, after the break, we will have to continue with our lesson. Have fun!
The Radyo Z-eskwela program of the Division of Davao de Oro is being brought to you by Nueda Builders Construction and Supply Incorporated, Maverick Builders Incorporated, Mitch Construction and Supply, Arquicon's Architectural Construction and Supply, DB Construction and Supply, Hanaway Builders Corporation, Phoenix Corvada Tagum Gasoline Station, Master Construction and Supplies, Mackenzie Builders, GP&H Construction Incorporated, Metro Gear Construction Corporation, NEN Builders and Development Services Corporation, Max Mays Enterprises Incorporated, We Inc. Construction Company, Rangay Construction and Supply, East Sussex Enterprise, WM Construction, Councilor Boogie and Miss Marjorie Vertodazo, Icon Builders and Supply, and Apex Mining Company Incorporated.
Welcome back to Science 9. Are you now ready to our discussion for today about formation of an ionic bond and covalent bond?
But before that, how about your activity? Are you done answering it? If that's so, please place your answers to your portfolio and prepare yourselves for the discussion of our topic.
Hi there! Welcome to our topic today, formation of an ionic bond and covalent bond. What comes to your mind when you hear the word ion? You may have seen it in some drinks or on the battery packs of your gadgets and devices. But in this video, we will be discussing first regarding ions. So let's get started. Ions are atoms that carry either a positive or a negative charge. These charges are a result of atom gaining or losing electrons. But how do atom gains or lose electrons? We know that in an atom, electrons orbit around nucleus. The valence electrons are the electrons found in an outermost shell of an atom. These are the electrons that are lost or gained in the process of forming ions. The elements in the periodic table are arranged according to increasing atomic number. The rows are called periods, and columns are called groups, which is numbered 1 and 2 respectively. Group number in the periodic table gives us the numbers of valence electrons in its outermost energy shell. For example, carbon, which belongs to group 4A, has 4 valence electrons. Electronegativity is the ability of an atom to attract electrons. The higher the electronegativity value of an atom, the higher is its ability to attract electrons. In period 2 of the periodic table, fluorine is located at the rightmost part of the row. Hence, fluorine has the highest electronegativity value, and it is the atom that is most likely to attract electrons. Thus, it has the highest tendency to gain electrons and become negatively charged. Generally, non-metals are the ones that tend to gain electrons and become negatively charged ions. They are called anions. When atoms gain electrons in its outermost shell, the number of their negatively charged electrons exceed those of the positively charged protons. Thus, they carry a negative charge. Ionization energy is the energy required to pull or remove electrons from an atom. This energy breaks the attraction between the nucleus and the valence electrons. The lower the ionization energy value of an atom, the easier it is to remove an electron from that atom. In period 2 in the periodic table, Lithium is located at the leftmost part of the row. And if the element having the lowest ionization energy, it has the highest tendency to lose electrons and become positively charged. Generally, metals are the ones that tend to lose electrons and become positively charged ions. They are called cations. Atoms that loosen electrons in its outermost shell carry a positive charge because by losing electrons, the number of positively charged protons exceed those of negatively charged electrons. Electron affinity is the energy that an atom releases when it accepts an electron. It is therefore a measure of the tendency of an atom to attract an electron. Atoms are electrically neutral despite them having charge of atomic particles like the negatively charged electrons and the positively charged protons. Atoms are neutral because the number of negatively charged electrons and positively charged protons are equal. Thus, an atom is stable. Atoms need to lose or gain electrons in order to be stable. They become stable when their outermost part of the shell or valence shell contains 8 electrons, which satisfies the octet rule. So what is the octet rule? Octet rule refers to the tendency of atoms to prefer having an 8 electrons in the valence shell. When atoms have fewer than 8 electrons, they tend to react to form more stable compounds. Remember our example about fluorine when we discussed about an ion? We learned earlier that fluorine has the highest electronegativity value in the period, and it is the atom that is most likely to attract electrons. Why not neon? Because neon is a noble gas or stable element. They already have 8 valence electrons, and they are called noble because they don't have to lose or gain electrons in order to satisfy the octet rule. To illustrate the atoms from their neutral state to their ionized state, we make use of the Bohr model. Here is fluorine in its neutral state. Fluorine has 7 valence electrons and thus need another electron to be stable. In its ionized state, fluorine will be negatively charged due to the addition of another electron. In this state, fluorine is now stable. It has followed the octet rule. The size of the anion fluorine increase due to the repulsion among valence electrons. Here is the lithium in its normal state. It has 1 valence electrons to be stable. Lithium needs to lose its valence electrons and be positively charged. The size of the cations with its lithium decreases due to the reduction of valence electrons in its shell. Now, let's wrap things up. Ions are atoms that lose or gain electrons. And ions are negatively charged ions because they have more electrons than protons. Cations are positively charged ions because they have more protons than electrons. Valence electrons are electrons in the outermost energy shell of an atom. These electrons are directly involved in any chemical activity. And now, let us proceed to covalent bonding. What do you think is its difference from the ion bonding? Well, covalent bonding, also called molecular bond, It is a chemical bond that involves sharing of electron pairs between atoms. It commonly occurs when two nonmetals bond together. When you say nonmetals, it has strong energy attractions or high electronegativity compared to metals. They do not need to give electrons to be stable. Instead, they gain or share electrons to gain stability. For now, let us see the periodic table on where to find the nonmetal elements to be used in covalent bonding. In our periodic table, we can see the nonmetal elements in the right side. Remember, they are not the only ones we call nonmetal elements. It also includes the hydrogen. Aside from nonmetal elements, metalloids can also be involved during the covalent bond, depending on the situation. There are two types of covalent bonding: the nonpolar covalent bond and the polar covalent bond. Nonpolar covalent bond is when electrons are shared equally. For example, hydrogen has no electronegativity difference. Hydrogen has only one electron in its covalent shell. Thus, it needs another electron to become stable. If we apply the concept of covalent bond, hydrogen needs another one covalent shell to achieve stability. It could be possible if meeting another non-metal element that is willing to share with its electron, which will make them both benefited. Let's use another hydrogen atom so that we can come up with the hydrogen gas with the chemical formula of H2. Because they both need one electron each in its respective valence shell, they are going to share electron so that they could be stable without losing electron. It pertains to single bond. It happens when two atoms share in a pair of electrons. Another example is the two oxygen atoms to obtain oxygen gas, which has chemical formula of O2. Here, two oxygen atoms has both 6 electrons to its valence shell. Both of them need 2 more electrons to become stable. Thus, they will share electrons according to how much they need to meet stability. Of course, double covalent bond happens when two atoms share 2 pairs of electrons to obtain stability. The same thing happens to the triple bond. What is polar covalent bonding? Remember that the concept of covalent bonding that no element shall give up and no element shall gain. Instead, both of them shall benefit or will share only because both of them need one electron to share to achieve stability. Example: 2 atoms of hydrogen plus 1 atom of oxygen. As you can see, they both have different electrons in its valence shell, yet they have the same desire, that is, to achieve stability without gaining or losing. It could only be possible if 1 atom of oxygen shared to the 2 atoms of hydrogen, so that both of them will benefited. If they share each other and become stable, we come up with the so-called water, which has a chemical formula of H2O. And now, let us sum up our learnings regarding the formation of ionic bond and covalent bond. In terms of elements involved, ionic bond involves metal and non-metals, while covalent bond involves 2 non-metals. In terms of process, ionic bond transfer of electrons, while covalent bond sharing of electrons. In terms of boiling point and melting point, ionic bond is high, while covalent bond is low. In terms also of polarity, ionic bond is high, while covalent bond is low. In terms of state, ionic bond is solid state at room temperature, while covalent bond is liquid or gaseous at room temperature. And that concludes our discussion for today regarding the formation of an ionic bond and covalent bond. Please prepare yourselves for the short assessment after the break. Happy learning, grade 9 students of Davao de Oro!
The Radyo Z-eskwela program of the Division of Davao de Oro is being brought to you by 𝗦𝗵𝗲𝗵𝗵𝗵 Construction and Supply Incorporated, 𝗏𝗵𝗵𝗵𝗵 Incorporated, 𝗦𝗵𝗲 Construction and Supply, 𝗡nci𝗲𝗃 Architectural Construction and Supply, DB Construction and Supply, Hanaway Builders Corporation, Phoenix Corvada Tagum Gasoline Station, Master Construction and Supplies, Mackenzie Builders, GP&H Construction Incorporated, Metro Gear Construction Corporation, NEN Builders and Development Services Corporation, Max Mays Enterprises Incorporated, 𝗣𝗿 Construction Company, Rangay Construction and Supply, East Sussex Enterprise, WM Construction, Councilor Boogie and Miss Marjorie Vertodazo, Icon Builders and Supply, and Apex Mining Company Incorporated.
It's assessment time. I hope you are all ready for our assessment for today. Here's the instruction. I want you to get a piece of paper and provide me with your answer. I am going to read the question twice. And I am going to begin with question number 1. How is covalent bond formed? Letter A, transfer of electrons. Letter B, sharing of electrons. Letter C, losing of electrons. Letter D, gaining of electrons. I repeat, how is covalent bond formed? Letter A, transfer of electrons. Letter B, sharing of electrons. Letter C, losing of electrons. And letter D, gaining of electrons. Moving on to question number 2. How many types of bonds can oxygen atom form? Letter A, 1. Letter B, 2. Letter C, 3. Letter D, 4. I repeat, how many types of bonds can oxygen atom form? A, 1. B, 2. C, 3. D, 4. Let's have the third question. What kind of bond will result when two nonmetallic atoms combine? Letter A, ionic bond. Letter B, metallic bond. Letter C, covalent bond. Letter D, nonpolar covalent bond. I repeat, what kind of bond will result when two nonmetallic atoms combine? Letter A, ionic bond. Letter B, metallic bond. Letter C, covalent bond. Letter D, nonpolar covalent bond. Moving on to the fourth question. In H2O molecule, the atoms are held by letter A, ionic bond. Letter B, metallic bond. Letter C, polar covalent bond. Letter D, non-polar covalent bond. I repeat, in H2O molecule, the atoms are held by letter A, ionic bond. Letter B, metallic bond. Letter C, polar covalent bond. Letter D, non-polar covalent bond. We are now on the last and final question. The fifth question. A covalent bond, letter A, involves shared electrons. Letter B, is formed by sharing protons. Letter C, results from the transfer of electrons. Letter D, it is called electrovalent. I repeat, a covalent bond, letter A, involves shared electrons. Letter B, is formed by sharing protons. Letter C, results from the transfer of electrons. Letter D, it is also called electrovalent. Are you done with our assessment? Great! And that concludes our lesson for today. We hope that you learned something from the discussion about photosynthesis and respiration. Keep safe, everyone. God bless.
Z-eskwela Executive Committee. The School's Division Superintendent, 𝗡mě𝗲𝗶𝗵𝗵𝗳𝗏. Assistant Schools Division Superintendent, Dr. 𝗦𝗵𝗲𝗹𝗵𝗵𝗳𝗏. OIC Curriculum Implementation Division Chief, Karina S. Frasco. School Governance and Operations Division Chief, Dr. 𝗦𝗵𝗵𝗵𝗵𝗵. Members, Cecilia Morales, Dr. Hilda A. Opeña, Dr. Arlene B. Lim, Dr. 𝗡𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵𝗵 𝗦𝗵𝗲𝗃, Dr. Grace D. Pontillas, 𝗡𝗵𝗿𝗺 Juanito Lapiceros, Engineer Norberto S. Manlangit, Jomar M. Dumupoy, Bob Daylan S. Milabat, Medard T. Ampit, and Paz Eugenia Villusino. Technical Working Committee, Productions and Communications, Lorely E. Quijano, Given G. Hinampas, Judyland D. Yu, Donna D. Bolfer, Mary Rose N. Resma, Riven Manuel, Irene Lea C. Manguhon, and Bessie Aya N. Banias. Social Media and Packaging Team, Christian and Hara L. Martesio, William R. Ranara, Joan T. Iscoton, Roberto S. Acusar Jr., May B. Istanyol, Richard H. Arellano, Lee L. S. Blanco, Ralph A. Tabanyag, Angelo Gutierrez Jr., and Jade Karen Araiz.